need a volunteer to get a pen, and I need somebody with a watch. We have a couple of ice blocks in distilled water. Okay? So what's the temperature going to be reading now? It's going to be reading 0, okay? Because there's ice and water in the same container, and we're keeping the thermometer close to the ice. Okay, so it's going to read. When you do this practical, you'll see that's the label on the thing that should be going around is grade 10. Okay, so in grade 10 you will do this practical yourselves. It won't be demonstrated for you, and you will have to write it up yourself as a research assignment. Okay, with your aims and objectives and all that stuff that we learnt about in the beginning of the year, right? So you are going to do that yourself in grade 10. Obviously, because we're starting at 0 degrees, we're going to be starting at remember that graph that I drew for you last time? We're just going to be starting on the flat part of the graph. Then as soon as all the ice melts, or as soon as enough of the ice melts, that some of the water will start to heat up, we're going to get the climb, and then we're going to start boiling the water. We're going to get to that second flat line of the graph, okay, to show you, and you will see that the temperature, while it's all liquid, you'll see that the temperature climbs, and while it's still got ice in there, you'll see that flat part of the graph, and when you start to get steam, you'll see it flattens out. Okay, when you do this, don't put too much in the beaker. Okay, we just want enough that we can get the thermometer in there without touching the side of the glass. Okay? Because if we touch the side of the glass, obviously the Bunsen burner is going to be heating the glass, and we're going to be measuring the temperature of the glass. Okay. Right, so we can see all the way from 0 to 100. Right? Yes, so when I put the Bunsen burner, it's still saying 0.
Yes, sir.
Right, so when I put the Bunsen burner under, you're going to start the clock. Go. Every minute, take a temperature reading.
Only every minute. That's how much time.
So what's happening now, like read the words in those notes that I've given you. Okay, what's happening now is we are adding thermal energy, right? So the kinetic energy of the molecules is increasing all the time, but can you see that the temperature is not changing? Watch the clock.
Still 0.
Okay, you can see that the temperature is not changing, hey? Okay, still 0. Right. So you can see now, for real, that what I was telling you is happening. Okay, you can see we are adding heat energy. So the thermal energy is being absorbed by those particles, and that there must be an increase in kinetic energy. Okay, therefore, because energy must be conserved, it can't vanish and go somewhere else. That energy is being absorbed by those water particles. What is the energy being used for? What's the energy being used for? If the temperature is not going up, what's the energy being used for? That's what's making the state change happen. Okay? It's weakening the intermolecular forces, and the ice particles of water are changing from solids to liquid.
What's the time?
Okay guys, so now all the ice is gone, right? So we've got no more ice in the water, so it's all liquid water. So we've only got one phase present. Okay?
Time. 37.
So, and you can hear from the temperatures that are being called out every minute that what's happening to the temperature?
It's increasing.
It's increasing. What was happening in the beginning when we had lots of ice?
Constant.
It was constant at 0 degrees for a little while. Okay? So now that we have only liquid, we're still adding thermal energy there's still the particles are absorbing that thermal energy and increasing their kinetic energy. Okay, as a result of the increase in kinetic energy, the temperature is now going up. Okay, what's happening to each of those particles while it's happening? They're moving around faster, and they're trying to. The intermolecular forces are weakening, and there is expansion happening, although it is microscopic. Okay, but the volume of water is increasing slightly all the time as we add in heat. Okay?
I don't want to go from this. 45.
So you must use those words in that way. Okay? That's why I've given you the notes. So we're now sitting at just above 90 degrees. We've reached the point where the temperature is starting to stabilize. It's becoming difficult to elevate the temperature. What is happening is that the thermal energy that we are getting from the Bunsen burner, which is being used to increase kinetic energy, is now starting to be used to convert the liquid water to steam. You can see there is steam starting to form in the container. Not all of the water is at uniform temperature, so we are getting bubbles starting to be formed. And that is the change of state that is starting to happen is the reason why the temperature is starting to stabilize. So despite the fact that we are still adding thermal energy, the temperature in the beaker is stabilizing, and we are starting to get the change of state forming. As I leave it for a little bit of time, you can see that more and more bubbles are forming, so that is boiling starting to happen. Those bubbles are not air bubbles. There is nothing but H2O, gaseous water or steam inside those bubbles. It is not air, it is not nitrogen, it is not hydrogen. It is pure water inside those bubbles. You'll also notice that the bubbles are being formed on the bottom of the beaker, because that is the hottest place where the heat is being applied. So that is where the water is at the hottest, and that is where boiling will start to happen. Now it is obvious that boiling is happening. We are getting some bubbles starting to form, and rapidly the water is being released as gas. You can see it visually there now, and you will see the temperature is remaining constant. So we are at 95 degrees. Obviously we have dissolved solutes in the water, so we're not dealing with pure water, so the boiling point is not at 100 degrees. But we are getting boiling happening, we are getting gaseous H2O being formed, and we are getting a change of state with the stabilization of the temperature, as the energy that is being added and absorbed by the water is now being used to weaken the intermolecular forces, and the change of state is able to happen. So here we have the data chart and the graph made by the grade 8 during the lesson, and here I have transcribed all of that data into Excel and then made a graph out of that. You can see that from 0 to 2 minutes we had no elevation in temperature, while we had both ice and water present. So two phases present during that stage in the graph, solid and liquid, and all the energy that is being added in the form of thermal energy is being used to break those intermolecular bonds and allowing the phase change to happen, and the temperature is stable. Then from 3 minutes onwards we have an elevation in temperature. I believe from 3 minutes till 8 minutes we still had ice in the beaker, but not all the water is at uniform temperature, so the thermometer was reading an increase in temperature. From 8 minutes onwards until 21 minutes we had a steady climb. We there have only one phase present, that is the liquid phase. During the liquid phase we are still adding thermal energy, which is still causing an increase in kinetic energy. However, now as there is only one phase present, that increase in kinetic energy now causes an elevation in temperature. From there we then move on to the next phase of the graph, which represents boiling. During boiling, again, not all of the water in the beaker is at uniform temperature, but clearly we could see steam starting to be formed at that point. And what is happening is that some of the energy for the proportion of the water that is boiling in the beaker is being used to make that state change happen. Then for a period we get a slow elevation in temperature until the water reaches 95 degrees. At 95 degrees we hit uniform temperature and the temperature stabilized. We then got visible boiling, in other words the formation of those steam bubbles happening. We could see it with our eyes. And we then have all the water at uniform temperature. Two phases are present, that being liquid and gas, and the phase change is happening. During this boiling phase, we are continuing to add thermal energy to the water, which is still causing an increase in kinetic energy. However, there is no elevation in temperature. The reason is that the energy is being used to break the intermolecular bonds between the liquid water and changing the liquid water to gas, which is then allowing the gas bubbles to be released. The important factor to remember is that during the phase change, the temperature remains stable.